Greetings. In this video we are going to compile our code and generate a hex file. So we will see how to do that. So I will open the folder which contains the file that I wrote last time, blink.c. Now I am going to open a terminal. So this terminal window, I am going to compile this code. So the command that I am going to use is avr-gcc. You need to make a note of this command, and then I am going to optimize the code for size. So I will put -o s. Why I am doing this is because space in our microcontroller is very limited, so we have only 16K, so it would be a good idea to always optimize our code for size. Next I am going to specify the CPU frequency, so I will give -f CPU equals, our CPU frequency is 8 megahertz, so 8 followed by 6 zeros, 1 2 3 4 5 6. It's an unsigned long value, and the output file that I want is blink. So the input file is blink.c. I want the output to have the same name without the extension, so I will give dash lowercase o and then blink. Here you have to be careful. For optimization you are going to give uppercase O. For the output file you are going to give lowercase o followed by our file name. The file that you are going to use is blink.c, and then very important, you need to specify the type of MCU you are using. So put -m MCU, that is equal to the microcontroller that I am using is ATmega16A. Okay, the command is avr-gcc. This is the compiler. -uppercase O yes, optimize for size, -f CPU, the CPU frequency is 8 megahertz. The output file, you need to give the output file name by using -lowercase o. This is my input file and the type of microcontroller. Now you can click on enter. It has compiled. So if you give the ls command, you will see that it has generated a file called blink. Now we'll see what type of file this is by using the file command, file blink. See, it is an ELF 32-bit executable file for Atmel AVR 8-bit microcontroller, but we don't want this. What we want is an Intel hex file. So we are going to convert this ELF file into a Intel hex file by using the command avr-objcopy. Then I will put -uppercase R dot eeprom. I am going to remove this section, that is why I am using -uppercase R. Then the output that I want is -uppercase O ihex, Intel hex format. So which file you need to convert? You need to convert the file named blink, and the generated file should have the extension .hex. So I will give blink.hex. So avr-objcopy, remove the eeprom section, and you are going to generate an output Intel hex file. The file that you are going to use as input is the blink ELF32 file, and the output file name is going to be blink.hex. I will press enter. I will give ls. See, blink.hex has been generated. So you can use the file command again, blink.hex, to check what it is. So you see, it is ASCII text. So now we are done. We have generated the hex file. We will now test it on simulide. So I'm going to click here, right click, load firmware, and I'm going to go to the location where I have this. Okay, blink.hex. Okay, now the firmware is loaded. So now I am going to run this. See, once I power it, the LED has started blinking. Right? So our code is working. You can also check it by clicking on the RAM table and examining the port B registers. So I want to examine the DDR-B register. See, the LSB is 1. Then I will have a look at the port B register. The LSB is toggling between 0 and 1. Right? So our code is working perfectly fine. You can stop this and save it. Now we are ready to upload this or flash or microcontroller by using the AVRDUDE software. So what I will do is I am going to connect my programmer to the development board, and I am inserting the programmer to the USB port. Now I have inserted it. Now all I have to do is flash this hex file onto the microcontroller. So for that I am going to use the avr-dude command. avr-dude, and then I need to specify the part number. So -P. The microcontroller that I am using is ATmega16A, and then the programmer that I am using. I also want everything to be verbose, so I will put -V, and the programmer that I am using, I will specify using -C. It is USB ASP programmer, and then the operation that I want to do is I want to flash it. So the operation is specified by -U flash. I want to write to flash memory, so put W. Then the hex file. The hex file is named blink.hex, blink.hex, and its format is Intel hex format. So I will put I over here. Now I will click enter. I will press enter. So I got a message over here. Okay, it has not been able to find ATmega16A, so it has listed out all the parts. So I will check. Okay, you have ATmega16. Okay, for that I can specify M16. Okay, we will see if there is ATmega16A. It doesn't seem to be here. Okay, so I am going to change the part number to M16, and then try again. Okay, now it's programmed. See, our low fuses are FF. This is what we did last time. And then if we scroll up and see, so it has read the device signature, low fuse is FF. That means you can use the 8 MHz clock. And then it has written 156 bytes of flash, and it's also verified it. So everything's fine. My microcontroller has been programmed. So in the next video I will connect LED to PB0 and then demonstrate it's flashing or blinking. Okay, so I'll see you in the next video.